Now it's recording. Okay, super. Now I copy again equation number 1, que es 4x squared plus 13x minus 12. Giovanni, let's start cool. Less than 0. This is a typical polynomial inequality. Polynomial inequality. So again, in this case, polynomial inequality, always you need to guarantee that the right hand side is 0. Oh, it's 0. It's already 0. And you factorization this trinomial. For factorization this trinomial, let's do it separately. Factorization is intermediate algebra. Okay. We're doing the factorization, this expression. Your multiplication 4 and 12 is 48. And you try to find 2 factors of 48 somehow when you're adding or subtracting, give me 13. The combination is 16 and 3. Because 16 times 3 is 48, and 16 minus 3 is 13. Okay, when you find the combination, well, you copy exactly the first. You copy exactly the last, minus 12. And you split 13 using 16 and 3, like that, plus 16x minus 3x. Okay? The thing that we are doing is the conversion, trinomial 1, 2, 3, and polynomial 1, 2, 3, 4. Now I am ready to apply factorization by grouping. By grouping this couple and by grouping this couple. The great common factor in the first couple is obviously 4x. Open the parentheses, we have x plus 4. And the great common factor in the second is negative 3. This is x plus 4. Do you see that? Let me check it just in case it makes mistake or not. Negative 3 and times x is negative 3x, and negative 3 and positive 4 is negative. Good. Now, I discovered that x plus 4 is common factor. I factor out one more time. And inside the new parentheses, we have 4x minus 3. Okay, so I just copy this here. Okay, x equivalent to say x plus 4 parentheses 4x minus 3. Everyone follow me? Everyone understand very well this part or no? Do you understand very well this part or not? The factorization is, I suppose that you know, right? This is intermediate algebra. Okay, teaching in the morning this semester. No problem with the factorization. Okay, now I temporarily, I convert this inequality. Okay, by the way, I want to enclose in the box because actually this is the inequality we are solving. It's equivalent, you know, as original, but this is more clear to understand. Okay, now, you convert temporary to equation because I want to find the critical value. So you copy x plus 4, 4x minus 3 equal to 0. Es in order to find the critical value. Entonces, x plus 4 equal to 0. That means that x is negative 4. And 4x minus 3 equal to 0. So for x, you move 3 to the right-hand side, divided by 4 is x equal 3 over 4. By the way, 3 over 4 in decimal is 0.2075. What is important to express it in decimal? Because now it's the graphic part. And the graphic part, guys, this is the way I want to see the solution. The solution has factorization number 1, compute the critical value. This is the critical value. Critical value are negative 4 and 0.75. Now, using my rule, I create the complete geometric picture about this problem. Okay, you put the famous all real number line. I need to see in the test this. No real number, 0. No table, 0. This is impossible doing in another way. Okay, this is infinity positive. This is infinity negative. This is 0 in the middle. And negative 4 here, negative 1, negative 2, negative 3, negative 4. I suppose here the critical value. And 0.75 is a decimal in between 0 and 1. Close to 1, no? Okay, I suppose case, approximately like that. Boom, 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 boom. I make a partition here and here. So we have basically in this moment 3 intervals. This interval, this interval, and this interval. Because we have 2 critical values, no? So we split the number line in 3 intervals. And you pick completely arbitrary testing point. And the testing point, for example, I pick, I don't know, one testing point and -5. It belongs to this interval only. It's 0. 0 is easy to evaluate. It belongs to the second interval, and 2 or 3 or 4 or 5. Remember, it doesn't matter the value that you select. This point I put in the cross red color is the testing. And testing point help me to find the solution. Okay, now I create the table. The table is black color. In black. The table is one table que contain TP, testing point. How many testing point? 3, -5, 0, and positive 2. And the factor in our problem is 2 factors. X plus 4, this one, and 4x minus 3. This one. And attach the total column in which I summarize everything. Doing plugging in -5. When you plug in -5 plus 4 and negative. Because it's -1. -5 here is -20, -23 is negative. Double negative is positive. This is important information that we need. The table total, the column total. 0 is positive, 0 is negative. This is negative. 2 is positive, and 2 is obviously positive. However, you know that our original inequality contains the symbol less than 0. And this is equivalent to be negative. Therefore, in the table, the only row gets true is the second. This is true. Because it's negative, the other is false, there's no solution. Therefore, the only testing point que pass the test is 0. Therefore, that indicates us that the interval is true is this interval. Include the endpoint? No. Why no? How do you know that no? Because we have no equal sign in our inequality. No equal sign, no include endpoint. Equal sign, yes, include the endpoint. Therefore, include the endpoint means no include, sorry, parenthesis. Then what is the final answer? The final answer is answer. In interval notation, always you express any answer in the test using interval notation. No, I don't want another way, guys. No. Es paréntesis -4, 0.75, I guess so. Or either way you want is -4, 3/4. Positive. This is the final answer. Okay. Any question? Do you understand very well this one? Question. Come on. Opinion. Let's review. In the review, I am doing fast. Because I suppose you know. However, any question, it's my pleasure to clarify that. Okay, go ahead. Question. No? Zoom up. Everyone, zoom up.
So
Go ahead, go
because
ahead.
it's,
Say
so
again.
because so because it's in between the two values, that's why you have it in the parentheses because it's in between the two.
No, 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 no. This is not exactly the idea.
Okay.
The idea is, you understand that our interval is the interval que I highlight in yellow color. Yes or no?
Yes.
Eso. Ahora, what about the endpoint? The understanding of the endpoint, okay, in our example, -4 and 3/4. You try to see in the original inequality. See, the original inequality is just a strict inequality, no equal. Therefore, the endpoint is not included inside the solution. Suppose I change that problem. I put equal sign here, equal sign here. No, no. It's no, I don't want to affect, pero suppose que es equal sign. Entonces, the answer is the same, except que include the endpoint. Entonces, bracket -4, comma 3/4 bracket. Bracket, bracket. Super? All clear now? Got it. Okay. Okay, guys, slow down. It's important that you understand 100% today. I don't want any problem. I don't want get you fail the test 3. No, you pass the test 3 and you improve your grade. Any question? No? Okay, let's move on to the question. Okay, question 2, 3, 4, and 5 is graphic. And remember, I would like that you are doing in decimals. Pero no, okay, let's do it by hand first in the whiteboard here, and after you see my word in decimals, no? Okay, let's do number 2. Number 2 is a classical example of the rational expression in which you have division to polynomial, no? Polynomial on the top is degree 1. By the way, polynomial on the bottom is also degree 1. Okay? Pero let's do it step by step. The first step always is expressed in factorial form. In factorial form, the idea is factorization the polynomial at the top and factorization the polynomial at the bottom, totally independent. In this case, we cannot do anything. Stay the same, and there are perfect coincidence between the original and the factorial form. One fantastic conclusion in that part is that we have no hole. We have no holes. Because remember, the hole is a factor this cancel out. This case, no cancel out anything. Okay, what is the next step? The next step is computing the y-intercept. Y-intercept is important point. Y-intercept, the formula is evaluate the function in 0. The function in 0, you take the original 0 over 0 plus 3. It's all because 0 over 3. The answer is 0. Therefore, the point is the point 0, 0. That 0 is x, is this 0. Okay, I enforce it. And this 0 was the answer, is this. 0, 0. So when the situation happens, normally we have only one intercept, que es 0, 0. Well, no, exactly. But well, this intercept is both, is x and y. Maybe, I don't know, in this example, we have another extra x-intercept. But I suppose que no. For finding the x-intercept, well, you put a function equal to 0. Que es equivalent, remember, it's a rational, and rational is division to polynomial. When you enforce a 0, it's equivalent to say that the top part is p is equal to 0. And this is a formula for finding the x-intercept. And how is p in our example? P is just x. That's x equal to 0. So there are perfect coincidence que es 0, 0. Repetition, x-intercept is both. It's x-intercept and y-intercept. Okay, this is not good because you expect 2 or 3 points, you have only 1. It's a coincidence. It's a coincidence. Okay. Everyone follow me so far? Everyone follow me? I'm doing fast. I know, okay, I'm doing fast. Pero you say stop, professor, if you don't understand. Okay, let's do it now. The next step is determine vertical asymptote. Vertical asymptote. And vertical asymptote is easy. Vertical asymptote is when the q of x is 0. Q of x is 0. Q of x is 0. Who is q of x? It's x plus 3 in our example. Therefore, x equal minus 3 is our vertical asymptote. It's a vertical line passing through -3. Okay, so now in this moment, I like personally start doing the graphic. How? Let's do it by hand first. Let's do it by hand. After, I promise you see elegant in this. And remember in the test, I repeat several times. You can do that in Desmos and you make a copy and send me the copy. No, it's more elegant, more clear, more, you know, you learn more. Okay, so far, the information that we have in my hand is, we have 1 point, que es 0,0. This is the both x and y intercept, this guy. And in -3, we have a vertical asymptote. Vertical, 90 degrees, totally vertical. Passing through -3. Boom, 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 90 degrees, negative. And normally, you know, okay, we use in black color and dotted line to represent vertical asymptote. In general, asymptote is dotted line. Okay, this is our vertical asymptote. Okay, by the way, the equation of this asymptote is x equal minus 3. Okay, super. What's the next step? The next step is determine if we have horizontal or slant. And remember, to understand horizontal or slant, you analyze the degree. Okay, actually, I did that. Degree 1, degree 1. When the degree is the same, yes, we have horizontal. Absolutely. Horizontal, yes, we have. At what value? Well, value is the coefficient of the division, of that coefficient que es invisible 1 and divisible 1. Entonces, the horizontal es y equal 1. Ese es a horizontal line. Wow, horizontal asymptote, sorry. Okay, of course, horizontal line. Let's do it now, the rule again, but instead of 90 degrees, you put 0 degrees because it's horizontal. Passing through 1, positive 1. There you go. Here, over there. A ver, 0 degree. 1, horizontal. Again, I use in black color, dotted line. This is my horizontal asymptote. Okay, super, horizontal asymptote. Equation, this asymptote is y equal. Okay, normally we check in just in case if the curve, okay, the curve is the original curve, the original function, this function, cross it or no the horizontal asymptote. To verify that, you take the equation of the function, que es x plus 3, and you enforce it to be equal 1, que is the value for the horizontal asymptote, 1. And you try to solve this equation. You apply cross multiplication, maybe, to say x times 1 is x plus 3 times 1 is x plus 3, and you try to solve this equation, but definitely you cannot, because when you move the x to the other side, this is 0 equal 3, and you get contradiction, totally false statement. That means that our function never is equal the value of the asymptote. Therefore, we have no, the famous point in which the curve crosses. Okay, nice, I like that. What more information we need? We need symmetry analysis. Symmetry analysis, because symmetry analysis allow me to determine si es even, si es odd. Symmetry analysis. is you make a reflection, change x for negative x, and you now, for example, you change any x for negative x. I did the reflection. Why not? To understand much better, you multiply top and bottom by -1. I know it doesn't affect. Entonces x, si you multiply this by -1, I change the sign, and this I change the sign, is x minus 3. Entonces, when you compare this new expression, que is the result of the reflection, with the original, you see that no, it's not the same. Entonces, no even, and it's no even, and it's no odd also, because odd is when it's opposite sign. Entonces, neither. Entonces, si es neither, okay, es neither, okay, es neither. That means that the positive part and the negative part are totally different. Yeah, I have to compute that. So now to compute that, you generate additional points, additional point. How many additional points? I have no idea. The last step is additional point. Let me hit here, additional point. For example, so far the only information they have is 1 point, they put in red color, and one vertical asymptote. And this guy helped me to split the number line x-axis and 1, 2, and 3 interval. So you for this similar to the inequality something, right? So you take the expression that is x divided by parentheses x plus 3, and you evaluate, and the point is what? For example, I pick, for example, I pick here 3. Because it's a little bit after this point, 3. And you evaluate the function 3. It's equivalent to say 3 over 3 plus 3, ¿no? Entonces 3 over 6, que es 1/2. Wow, 1/2. Entonces the point is 3,1/2. Okay, 3,1/2 look like here. That point. Because it's 1.5 is the middle here, the midpoint, no? Okay, super. I select why not another point in the second interval is this in between the vertical asymptote and the x-intercept. Suppose negative. And you evaluate the function and negative. Remember, I need to evaluate both positive and negative because the function is neither, no symmetry. So the negative 2 is negative 2 negative 2, I have no idea. Negative 2 divided by negative 2 plus 3. Say negative 2 over 1, and negative 2 is a coincidence. Negative 2, negative 2. So the point is negative 2 here, over there. But let me put in red color. Red color. And why not? Why more? One more in the last interval, maybe -5. Evaluate -5. So -5 is, let me see. Bueno, okay, es -5 over -5 plus 3. Entonces -5 over -2 is 5 over 2. Okay, by the way, 5 over 2 in decimal is positive. Because negative divided by negative is positive, is 2.5. So my point is -5, positive 2.5. Entonces es like that. -5, 2.5, 2 and a half of this. Okay. 5, 2.5. I suppose using my imagination, que es here. Okay, so using the information of the asymptote, x-intercept, and the additional point, and no symmetry, I suppose that my function look like that. Look, passing through this point, passing through this point, and this approach, but never touch the horizontals. And here, approach it, but never touch the vertical. I like what happened here. If you want to understand much better that part, you evaluate negative 4, maybe. Any question? Any question? What part is confusing? Come on, question. No? Okay, just in case, when I did that at home, but I want to make sure, because I send the professor the answer, and I want to make sure. Okay. Because I use Desmos. Okay, let me open Desmos. Okay, Desmos, I want to share the Desmos screen. You let me know si you see or no. Wait. Boom. Do you see or no? Super. Look at the question 2. Boom. Something like that. I make a zoom. You see clear like the water. We have here, look, we have here the function. This is my function. I put in red color. I put the famous vertical asymptote. I put the famous horizontal asymptote. I have several points, including x in a set, y in a set, and 3 additional points. In this case, I take different. I take 1, I take negative 2. This is the same. They are coincidence. And this and this, no? But no, because I take negative 5. Okay? You take arbitrary point, guys. You take arbitrary. Any question? Any question? Any question? Come on, any question? Let me see now.
I'm clear.
Exactly. Good. Very good. Let's move on now to whiteboard. May I erase everything? Yes, I suppose. No erase everything. Erase only the part I did. The other page not necessary to erase. Okay, let's erase that part. Boom. And we continue doing that. Okay, next graph, number 3. Oh, this is quadratic function. This is not rational. It's quadratic. G of x is equal x squared minus 5x plus 8. By the way, this is expressed in standard, not in vertex form. In standard form, in my opinion, is easier. So you are familiar with the quadratic equation, ABC. The A is in this example 1, positive 1. B is negative 5, and C is 8. Okay. Now, in the parabola, the most important thing is looking at the sign of the A. In this case, positive. It's a positive 1. That means our parabola open up. Right? Now, super important point is the vertex. Now, remember the vertex, normally we call H, K. A is the X component for the vertex, K is the Y component of the vertex. And the magic formula can help me to find H is minus B over 2. This is super important formula in this test. It says minus B is negative 5 divided by 2 times 1. Double negative become positive, 5 over 2, que is equivalent to 2.5. This is H value. The H is 2.5. What about K? Well, K, no formula, it's weird formula. But you evaluate G and 2.5. Or either way, if you prefer fraction, 5 over 2, you can do that. Let me try to use my calculator. In my calculator, I put x squared minus 5x plus 8, and you evaluate at 2.5. The answer is 1.75. Okay, therefore, the conclusion is the vertex is located at the point 2.5, 1.75. What more information we need? Well, we need the information that the most information that you can get, no? Entonces, important is the y-intercept, x-intercept. For finding the y-intercept is easier. Y-intercept is evaluate the function as 0, y evaluate 0. It's obvious that this always happens when you have a standard. S and C value, que es 8. Because when you replace x for 0, this part disappears and stay alive only 8. So the point is 0, 8. What about x-intercept? Well, x-intercept always is a little bit more complicated. You take the x function and force it to be 0. In other words, you need to solve in this inequality. No, sorry, this equation. That, by the way, is quadratic equation, no? And the easy way, I suppose there's no trivial value. So by factoring, no good. However, by quadratic formula, it's always possible, no? So it's A, again is 1, B is -5, and C is 8. You apply the quadratic formula. Actually, in the chapter 1, when you working with the chapter 1 and we solve the quadratic formula, the thing that we are doing is find the x-intercept of the parabola, pero the real value. Si es complex, no, because do not exist. In this case, double negative become positive. Plus and minus square root negative 5 squared minus 4 multiplication by 1 is 8 multiplication by 8 is 6 divided by 2 times 1. Okay, so now as always happen, you need to solve first the expression inside the radical. And expression inside the radical is 25 positive minus 40. Immediately you see that. It's 40 minus 25 is negative number. A negative number inside the radical is imaginary. So what is the interpretation of this? 40 minus 25 is 15, but it's negative 15. And negative 15. So when you find the square root negative 15, I know okay, this is I, square root positive 15. So immediately you see I, that means it's complex solution. And complex solution means in the real field, this point I try to find with my best intention do not exist. Do not exist. Okay, so, this parabola have no x-intercept. That means this parabola never crossed the x-axis. Well, okay. So now I am ready or no, or not yet? I suppose yes. Okay, let me try. Let me try to do my best. Again, I bring the rectangular coordinate system, the picture that represents the rectangular coordinate system. Boom. Okay, yeah, I know that in this example parabola. Okay, the important, super important point is the vertex. The vertex is located at the point 2.5, 2.5, and 1.75. Using my imagination, this is 2.5 in x, and 1.75 is approximate here. This is my vertex. See, this is my vertex. And the parabola open up. It's obvious you never cross the x-axis. It's obvious. However, the parabola, yes, crossed the y-intercept. And the point is the y-intercept. So y-axis crosses the y-intercept. Okay, by the way, it's an 8. So let me create extension a little bit, 90 degrees of the y-axis. Extension. Now we have 6, approximately 7, and 8. Boom. This point is the point 0.8. It's exactly this point. Okay, entonces my parábola, okay, one more information. Bueno, one more information is the axis of symmetry. Axis of symmetry. Axis of symmetry is always vertical line, x equal h. In our specific example, h is 2.5. It's a vertical line. It's a vertical line, 2.5, 2.5, 2.5, 2.5, 2.5. It's a vertical line. Let me try to do my best. Vertical line again, vertical line, passing through the vertex here, over there. Normally, using again, there's no asymptote, of course, it's a axis of symmetry, dotted line. And using my common sense, see a symmetry, axial symmetry, we can take advantage this fact to plot one point here. Okay, we have this point, sorry, and we have another point here que es symmetric, the same distance, que es 2.5 plus 2.5 is 5. So we have another point here que I don't compute using algebra ni arithmetic, using image symmetry, que es the point 5,8, because it's the same distance. That distance is 2.5. Look at that. And this distance should be 2.5. And 2.5 plus 2.5 is 5. Therefore, the point is 5,8 because increasing the x component, but the y component stays the same because it's the same image. It's symmetric. Okay, so we have a lot of information, a little bit, not too much, to do the graph of our parabola. Look like that. Our parabola, never I like parabola like that, guys. This is not parabola. Parabola is a smooth curve. Okay, smooth. And also something like that. Normally, we put an arrow here. This arrow indicates us that this parabola continues forever to the right and to the left. Ready question? Example, this is a question 3. No? Question 3. Let's see how we are doing this. Do you have any question or no? 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 Let me see in the smooth. Minimize. Share the screen. Boom. And boom. In this moment, I suppose. Can you see the smooth? Or no? You see or no? Okay, but this was the question 2. I want the question 3. The question 3 is the parabola, look. Boom. Look at the vertex. The vertex is 2.5, 1.75. It's a vertex. And the famous point is y-intercept 0.8. The new point you obtain by symmetry, using the axis of symmetry, is the vertical line, x equal 2.5, is 5,8. End the story. Any question? It's easy or it's complicated? Okay, let me see. Okay, I need to concentration in the share screen. Okay, there you go. Do you see the whiteboard? Okay.
Yes.
Super. Everyone follow me, guy?
Yes.
Yes, sir.
You promise that you get good grade in this test?
Yes, sir.
However, this test is more, in my opinion, is more complicated than the second. However, you are more interesting to improve, no? Okay, let's move to number 4. Number 4 is similar. It's also parabola. Es y equal negative x plus 3 squared plus 5. The only problem is that this is expressed in vertex form, but it's okay. And then you see 2 parabolas. One expressed in standard, ABC, another expressed in vertex form. And you need to remember that in the vertex form, you have a x plus minus h, square plus k. Like a general, no? Formula. for the vertex form. When you compare this equation and this equation, I can see, wow, A is -1. Why is -1? Because we have here invisible -1. H is -3. Why? Because in the original problem, I see plus. What is the reason, Professor, get plus? If the original equation contains negative. The problem is that H value is negative, and double negative becomes positive. And K no, K is 5. Therefore, I know two information about this parabola. Number one information, this parabola open down, sorry, because A is negative. The A is negative, open down. And the A is positive, open up. And the vertex is located at the point -3,5. Wow, it was easy. Was easy in that way because you see clear immediately what is H and what is K. Okay, and that's it. No, because I want more information. I want Y in the Z, X in the Z, axial symmetry, and finally try to find additional point using the idea for the symmetry. Okay, for finding the Y in a Z, always the formula is evaluating zero function. So in other words, replace X for 0. Entonces, -1, 0 plus 3, plus 5. Entonces, Y is equal, 0 plus 3 is 3, 3 squared is 9, 9 multiplied by -1 is -9, plus 5 is -4. Okay, entonces our parabola crossed the Y at the point 0, negative. Super. I have more information in this example. I have the vertex, I have open down, I have the Y and Z. Let me try to find X in Z. X in Z, X in Z, X in Z is f of X equal to 0. Remember, f of X and Y is equivalent. It's the same thing, the same, mathematical object. It's two different ways to express the same idea. So now, basically, the idea is that the Y is 0. So 0 is equal what? In our example, is negative X plus 3 plus 5. I forgot here square. And you solving this equation. By the way, I suppose it's quadratic equation, no? I suppose it's quadratic equation, of course. So I propose you doing the easy way. What's the easy way? Well, the easy way is, for example, you move this guy to the left. So it's X plus 3 squared equals 5. And you apply square root of sine because I take advantage. Can somebody do the factorization of this? So in my opinion, it's easier doing that way. And the square root of 5, unfortunately, is a rational number. That's plus or minus right of 5. And so for X is -3 plus or minus right of 5. But don't frustrate for this idea because actually, immediately when you have irrational, get real. But it's irrational. Irrational is a number that have infinity decimal place, but I don't care because you truncate, you round. So you take, for example, -3 plus radical 5. And -3 minus radical 5. And you put in a calculator the decimal approximation. And the decimal approximation is, in my calculator, I try to find out. -3 plus radical 5. Boom. Decimal approximation. Whoa, 0.75. 0.70. It's negative, sorry. Negative 0.76. Approximately 2 decimal places enough. Now, since minus, no plus, subtraction. Now, decimal approximation is -5 point something. -5.2 decimal place enough. 24 approximately. Okay, so we have to. So the parabola crosses the x-axis and 2 points. The points are negative 0.76, and negative 5.24, Remember the idea behind this was, okay, Y is 0. You enforce it, Y is 0. Here. Look, this 0 is this 0, y is 0. And you find the point that satisfies this condition. That's it. Well, temporarily, yes. Temporarily, yes. Let's try to now start doing the graphic. Okay, the graphic, let me see. The vertex of this parabola is located at the point -3, 5 here, over there. I know that this parabola open like that, open down. Okay. But passing also by the point 0, -4, que is here. Okay, so I'm supposed to open down. Also passing for the famous point -0.76, using my imagination is approximate here. It's impossible. Well, it's possible in this, but by hand, it's crazy. And -5 point something is -5.24, approximately like that. Okay, that's it. No, because we can find one additional point. Okay, the axial symmetry, passing through the vertex always. Okay, using black color, dotted line. And this is the line, hypothetical imaginary line, to split the parabola into equal parts. Therefore, I suppose using my common sense and my imagination, okay, we have another point here, right, of the parabola. Look, my parabola look like that. Ooh. Now we have another point here. This distance is 3, and this distance should be 3. So it's approximately -6, -4. Is the extra additional point that we obtain using the symmetry of the parabola. So let me try to do my best by hand. This is the parabola. Boom. Smooth here, no sharper point. No good. My parabola is no good. No, not good. Sorry, guys. This is it's a little bit hard to do using the pen, electronic pen. Okay, this is my parabola. Look like that. Okay, this famous point is the point -3, 5. This is the weird point, is this and this, and this point is this, and this point we obtain using my imagination, using the symmetry. However, just in case, to make sure, Professor, you go to Desmos and do it. 5 minutes. Let's do it again. Desmos now. Boom. Let me share the screen. Okay, Skype. Sharing. Switching to Desmos. Okay, boom. This is Desmos now. That was the last question, number 3. Now we're doing number 4. Number 4 is different. Look, this is number 4. Number 4 is a parabola. Do you see that or no? Look. This is the original parabola. This is the famous point, including vertex, x and z, y and z, an additional point for the symmetry. And this is my famous axis of symmetry. End the story. Beautiful. Fantastic. We are the best, Miami-Dade College. Any question? Do you see that? Do you see that? Sure. Guy, are you boring? You are attention. Remember, this is the review for the test. Okay. This is important. Very extremely important. In my opinion. Any question? Are you tired? No. It's okay? Okay. Let me erase the board and we continue for the next question. Next question is... Okay. Boom. Okay, next question is phi. Oh, yes, it's phi. Phi. And phi, again, is a rational. It's a rational function. Rational is the division to polynomial. Polynomial in the top is x squared plus 4x plus 3. Polynomial in the bottom is 9 minus x squared. Okay, entonces remember this 7 steps that we are doing to solve it. Step number 1, factorial 4. Factorial 4 consists in factorization, the polynomial in the top, and factorization, in this case, binomial in the bottom. Entonces, two paréntesis, x, 3, 1. Because 3 times 1 is 3, 3 plus 1 is 4, plus. I did that. The second, no. The second is the binomial. What kind of binomial? Different of square. And the factorization again is 2 binomial. Square root 9 is 3. Square root x squared is x, plus or minus. Okay? Something like that. This is the factorial 4. And my question is, we can cancel out something or no? We can cancel out something or no? Yes. Yes, because x plus 3 and 3 plus x is the same thing. I put intentionally to confuse you, but no, it's the same. You cancel out. So my question is, we have a whole? Yes or no? We have a whole? Yes or no? Yes, we have a whole. At what value is a whole? Whole, we have one whole. At -3, very well. And -3, I can see when you finish to do the graph, something like that. A whole. Okay, the x value is -3. And the x-axis is -3. Okay, I want to see it. And the new expression here obviously is easier than the original, is x plus 1 over 3 minus 6. You focus it in this new one. New one. Okay, by the way, this new one is equivalent to this except and 3. So this and this is the same, except and 3 and -3. Sorry. Okay. I understand very well this. Everyone understand very well this or no? Or you are a minimum doubt of this? No? Clear? Good. Okay, now I want to start step by step. What is the first step? My first, no, my second es y en z. Que es el valor de función es 0. Es 0 plus 1 over 3 minus 0. Es 1/3. The y in z, look at the point, 0,1. Super. X in z, remember, is you take the function equal to 0. Or another word, the top part is p equal to 0. I don't care the bottom part. It's not important. Entonces, x plus 1 equal to 0. Es -1. At the point is a point, -1,0. In this case, okay, you have only 2 points. We have only one in a set and only x in a set. And the reason is clear, because the polynomial in the top and the bottom are linear. Nice. What about vertical asymptote? Vertical asymptote, remember, if you take q equal to 0. Now who is q? Q is 3 minus x. So 3 minus x equal to 0. Therefore, x is equal to 3. And this is our famous vertical asymptote. And remember, this is a moment that personally I like to start the graph. Because you have not too much, but you have some important information. Let me try. Boom. Boom. This is my image of the rectangular coordinate system. Don't need horizontal. Yeah, of course. Okay, Clifford. Yes, you're right. However, I don't know why. In my mind, I want to do the graph in this. Of course, we have, yes, you are right, 100%. Okay, but at this moment, I suppose in my mind, I don't know why, but you finish everything and you were doing the graph. In my opinion, no sé, it's up to you. I plot the point. What point I plot? 0,1/3. 0,1/3 using my imagination is here, approximately, no? Because this is 1 divided by 3, you know, this guy, boom. And this guy is -1,0, this guy, boom. Plot that point. And we have vertical asymptote in 3, no? Okay. And we have a whole and -3. -3, we have a hole. The way I do it without a hole, and after the last moment, you put a hole. Okay, entonces one vertical asymptote in at 3. Boom. Here, over there. Black color dotted line. Okay, good for me. Clifford says, well, professor, what about horizontal? Yeah, we have horizontal. How do you know that we have horizontal? Because we are doing the analysis of the degree. Degree not on the region. Well, it doesn't matter. Degree and either way. Degree here is 1. And degree here is 1. Same degree, you have horizontal. Where and the division 1 here and -1 here. This is y equal negative. This is my horizontal. So it's something like that. Horizontal is 0 degree. Boom. And -1. And -1, que is here, over there. This is our horizontal asymptote. Okay, horizontal asymptote is the line. Y equal -1. And vertical asymptote was, I forgot, x equal 3. Let me verify if my curve crosses or no -1. How you determine that? Well, it's easy. You set out the equation, you put the expression, and you enforce it to be equal to -1. And let's do it. Let's do the solution of this equation. I propose you doing cross multiplication. You multiply x plus 1 times 1, and you multiply -1 times this case, -3 plus x. So now you solve for x, you try to do your best. This x stay here. I move this another x to the other side. -3 stay, -1. This is 0, and this is -4. This is completely contradiction, false. That means that the point I try to find do not exist. So there are not possibility to the curve. Okay, you try to do the graph crossing the x-axis. What about symmetry? Symmetry is reflection. Remember, you are doing a reflection by -x, and we compare the new expression. But we are doing in the new one, que es Caesar. No, it's equivalent. So now there are no reason to using the original, because the original is a little bit more complicated. You can do that. Why not? However, no. In my opinion, no. So it's -x plus 1 divided by 3 minus x. Okay, I try to do something. For example, I multiply top and bottom by -1, so x minus 1 over x minus 3. Because the negative here, negative is positive, and -1, okay, I multiply the bottom by +3 is -3. And when you see this and this, it's completely different. No even, no or, is neither. Okay. Okay, I checking. No? Si es no symmetry, well, entonces I need to do the positive part and the negative part completely independent. And now using, for example, at that moment, guys, you select arbitrary point. Where? What is the criteria to select arbitrary point? For example, we have the partition in the x-axis. What is the partition in the x-axis? The partition in the x-axis is this vertical axis and this x-intercept. So you, for example, you select 5, boom. For example, you select 2 or 1 or 0. 0 is perfect. And you select here in this dash interval -2 or -3 or -4, and you compute the y value. I don't want to do this because it's straightforward. And you plot that point. Let's do in decimal quickly. because it's, you know, this is basic arithmetic and consuming time for nothing. Entonces now in decimals, I want to share decimals. Boom, 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 boom. Do you see? Okay, this is example number 4, but I am doing number 5. Is this? Boom. Look at that. Number 5 is we have the function. The function I using a purple color to the function, no? And you, for example, I forgot the whole. I forgot the whole, guy. The whole is located at 3. Okay, the whole. Okay. This is the function. This is the equivalent function. I put in green color. Do you see that it's the same? It's a perfect coincidence, except in the famous point que is okay, the whole was, let me check in the whole was in -3, and -3. Entonces x plus 1, I write in my piece of paper, 3 minus x, entonces I evaluate -3, es -3 plus 1, divided by 3, minus is plus 3, entonces es -2 divided by 6, es -1/3. O sea, the famous point, I don't do that in decimals, but I want to do now, you see the process clear. Now, look, decimals. Oh, look, I did that. Sorry, coño, I forgot. Look, this is the whole, 0, -1 or 1/3. This is the whole. So this one in purple color represent the original, including the everything. But this one, okay, I remove that. Now let me see here, over there. This in green color is the new one without hole. Okay, it's exactly the same. They are equivalent, look, except the hole. Okay, the hole is this. Boom, boom. Okay, do you see that or no? Why not put a fraction here, over there? -1/3. Do you see that or no? G and -3 is a whole, yeah. Okay. The whole. How you find the whole? Let me try to explain. I come back to the whiteboard. And the whiteboard. Actually, wait for me. Be patient, because I'm not good when I share the screen. I am confusing. Okay, look. This is whiteboard, no? Whiteboard, yeah. Book. Look at that. Okay, good. The hole is located at, look, the hole is located, we discover in one moment of the time, okay, the hole is located at x equal to 3. So now to locate specifically the hole inside the rectangular coordinate system, we need the one value. I know that the y value is to be undefined. That is a reason to get the hole. However, I evaluate no in the original case, I know it's undefined. So f and -3, I know it's undefined. Undefined. However, a new one evaluate and -3 is, look, x plus 1 over 3 minus x, evaluate at x equal -3, and -3 plus 1 divided by 3 minus 3. So you replace x for -3, this is surprise. Look at that, it's -2 divided by double negative become positive, is 3 plus 3. Okay, 6. So it's -2 over 6. When you reduce on 1/3, it's -1/3. Now the hole is located at the position -3, -1/3. Negative? Negative or positive? Espérate, whatever. No, es negative. Es negative. Es negative. Es located the hole. Okay, entonces I suppose que the hole, o sea, approximately the graph look like that. Look at that. Let me try to do my best. Boom. I have no idea, but I suppose using my nature can look like that. Entonces, in that part, ooh, here we have the hole. And it's continue, approach, but never touch the horizontal. This is the famous hole. It is located at that point. Clear? And you put it, and you put arrow. In the arrow, the only information indicates that this continue forever. Approach it, but never touch. Super. Super, super clear. Super clear. Any question? Okay, let's do a number 6 now. I suppose for today it's okay. I don't know if it's okay. Let me try. Because maybe you are doing too fast. Okay, and the test, I guarantee you, the test is very, very similar to the review. Different number, of course, but similar. The same kind of number. So you see in the question 1, we have polynomial inequality. We did that. However, in the question 6, we have another polynomial, but this polynomial is different because somebody do make a favor to make the factorization. So 6 is x plus 5 multiplication x minus 4 squared greater than 0. And remember one thing. When you have factors that contain exponent event like that, you can delete it. But be careful because sometimes it's totally delete or partial delete. How do you know? See, my inequality contain greater than or equal is totally delete. See, my inequality, no, contain only greater than and not equal is partial. And what means partial? Well, partial means that our inequality is this. Is equivalent to say x plus 5 greater than 0 using that symbol, and temporarily you ignore that, guys. However, you put an and conjunction, and this is partial delete x not 4. Why not 4? Hey, noise. Again, noise. Because it's 4. 4 minus 4 is 0. And 0 never is greater than 0. That is a reason that you need to put this restriction. But this is easy because this represents a hole. But a hole in one dimension, not in 2 dimensions. It's a different hole. No, it's a hole. It's undefined. So now, again, I do in mine. When I do in mine, I solve in this piece, que es Caesar. I solve in this piece, que es Caesar. It says x plus 5 greater than 0. That means that x is greater than negative 5. And not 4. Okay, so in my number line, we have, look, boom. This is my ordinary number line. Now, this is positive infinity. This is negative infinity. This is 0, negative 1, negative 2, negative 3, negative 4, and negative 5. Is that part alone is the bunch of numbers. So the interval greater than negative 5 is to the right, to the negative 5. But in middle of the process, we found one hole in 4. So in 1, oh, you know, in 1, no, wait a second. Delete that. And 1, 2, 3, and 4, we have a hole. And that hole, I want to use a yellow color because I want to highlight everything in yellow color. Stop in 4, 4 as a whole, and continue. And what about the 5? No, no include 5, because I don't see equal sign here. Paréntesis. Entonces aquí es paréntesis and paréntesis. The final answer expressed in interval notation is -5 from -5, 4 union 4, infinity. Okay, this is super easy, super elementary. No problem. It's super easy. Okay, you can see in the test, of course. I guarantee you 100%. One inequality complicated, like a number 1, and one inequality easy, like a number 6, in which you delete something. And I promise que no totally delete, sino partial delete, que is a little bit more interesting, no? The partial delete is very, very straightforward. No? It's just ignore this guy and that's it. Do you follow me? Do you understand what is the reason que es delete? It's delete because any factor that contains even exponent is positive. And you know the positive have no influence in the inequality. The positive sign, no, it's important. The negative sign is important. How many negatives? You have 3 negative and negative. You have 4 negative, it's positive. And so the important information when you solve the inequality is the fact que somehow involve negative number. Si es positive always, entonces you delete complete. Si es 0 and 1 point, no, it's partial. Do you understand this one? Sure? Very well, guys. Guys, I feel que when I explain something, you understand. Tila. Entonces the problem is, please don't forget in the test, no? Don't forget in the test. Let me try to do in the test also, you can see 2-word problem. 2-word problem, like that, but it's super easy. Because this word problem talking about the parabola. Entonces we have 2 possibilities. The parabola open up or the parabola open down. When you open up, it's minimized. It's a minimum. Find the minimum something. When the parabola open down, you find the maximum. Okay, entonces in this number 7, this is the profit for the vendor make per day by selling X priceless is given by this. The formula is POX, price. Price, no profit. Is equal minus 0.002x squared plus 1.6x minus 200. Don't be scared with the number because we are using a calculator, no? Entonces, I determine immediately A in the parabola is minus 0.002, B is 1.6, and C is negative 200. And you find the vertex. Because the problem says maximize. Maximum, that means the parabola open down. And it's logical to open down because A is negative. Si A is negative, the parabola open down. And when the open down, you find the maximum value. And the maximum value occurs always in the vertex point. In conclusion, you need to find the vertex. What component? Well, depending on the question. Find the number of Presleys. Presley represents the X. So in this formula, it's about profit. Profit is money, dollar. And X is Presleys. So the independent variable is Presley. And the dependent variable is profit, is dollar. Let's see, they want to find how many, so not the profit, they want number of Presleys. So you find the X. In conclusion, the vertices have 2 components, H, K. In this case, they want you find only H, no K. You want to find the K, it's okay, but not important. And the formula for the H is minus B over 2. Okay, entonces minus B es 1.6. By 2 times A, que A is negative 0.002. And you put in a calculator. But okay, before you put in a calculator, you analyze if you have 2 double negative. And double negative is positive. And the answer is positive and make it sense. Because the Presley have no sense to be negative. So say 1.6 divided by 0.0202 multiplied by 2. Because the formula has extra 2. Close the parenthesis, boom. Wow. Okay, sorry. I make a mistake. It's double parenthesis. Boom. 400. 400 what? 400 bracelets. Is the answer. The answer is when you sell 400 bracelets, exactly 400, your profit is maximum. So you sell less than 400, no, it's not maximum. Or greater than 400, no, it's not maximum. If 400 exactly, the maximum value occur in the vertex. Then the answer is 400 bracelets. Bracelets. That's the final answer. Everything okay? So we continue next time doing the review. Okay? 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 No problem. Let me stop recording. No.